Hello, namaste, Mr. Bossert here. We're going to talk about solving quadratic equations today. Now, I haven't written the title up there, so it's our last, I think, video notes of the year. You've done a great job all year. Make sure you have your date and title on these as well. So, solving quadratic equations. So first I want to start off by talking about this statement here. If x times y equals 0, and what do we know about x and or y? Well, obviously, right? Yes, you're right, that either x is 0 or y is 0. One of them has to be 0. Could they both be 0? Well, I guess they could. This is something called the zero product property. And the zero product property is going to say that if a, b, the product of a and b is 0, then one of them, either a is 0 or b is 0, or both. This is a pretty important thing for us. Now, there's no zero-sum property. Any number plus its opposite, I guess, equals 0. That would be the inverse property of addition. But the zero product property is specific. It gives us some information about one or both of the factors. And so putting this into practice, if I have this equation that x times x minus 3 equals 0, from that then, because this is a product, essentially, right, if we substituted and we said that, AB equals 0, then A equals 0 or B equals 0, in this case, right, x has got to equal 0. Oh, what happened there? Or the b, the second factor, x minus 3. Now, just because it's a binomial, that thing that's in the parentheses essentially stands in place of b here. So either the x equals 0 or x minus 3 equals 0. Well, x equals 0, that's solved. If x minus 3 equals 0, then according to chapter 1 for us, x would equal 3. So I have two answers. From my work this year, I know that if I have two answers, there must have been a way that this was an x squared equation. And really, if I think of it, if I look at this, x squared minus 3x equals 0, these two terms both have what in common? What is a common factor of both of those? X is right. X goes into both of those. So it's almost like this problem, x squared minus 3x equals 0, this expression, x squared minus 3x, it's been like x has been distributed into both these terms. It could have been x, right? X distributed into what thing? Well, x times what would be x squared? That's x. And x times what would give you minus 3? X, that would be negative 3. So this, if you look in red here, if I would distribute the x in here, I would get this original 1. So this act of undistributing, in order to get something that we want to do here, is this is called factoring. Factoring is the opposite of the distributive property in some ways. It's what the thing looked like before you've multiplied. And so now if I take this expression but rewrite it by factoring out the common factor of x, now I have the same expression that I have up top here. And so I can use now the zero product property. Before here, this highlighted part here, right, that's not a product, right? X squared minus 3x is not a product. But once I factor out the common factor of x, now I have x times x minus 3. I can use that zero product property. Well, when the thing already is a product, and I have, again, a times b equals 0, a is x minus 7 in this case, and b is x plus 3, either the x minus 7 equals 0, or the x plus 3 equals 0. And so if I solve this, x minus 7 equals 0, add 7 to both sides, x equals 7. If I solve this, x equals negative 3. So my two answers are 7 or negative 3. There are two possible answers. Take a look over here on the right. And for these easy ones, I mean, these are easy ones because basically it has to be the additive inverse property says to get 0 here, x has to be negative 8. And to get 0 here, x has to be 12. So those are my two answers. Right, so however, now these two examples down here, it's not a product. X squared minus 4x minus 21, that's a trinomial that's equal to 0. So there's no subtraction equals 0 thing, because that could be anything. But I do know that since I have an x squared, or it's a degree 2, if we think back to the last note set, the second degree equation, there are going to be two possible answers. And one way to get those two possible answers is if I can make it a product. To do that, I have to take this trinomial and I have to factor it, in fact, unfoil it. Right? Unfoil it into what it looked like before I foiled. All right? Remember, for foiling, I'm telling you that this is x squared minus 4x minus 21 is the result of two binomials being foiled together. So what were those binomials? All right. In other words, what goes in these two parentheses? Well, the first product is I ended up with x squared. And the only way really to get that is if the first terms are x and x. The last terms are multiply these last two pieces together. Okay, and I've got to get negative 21. But the trick here is the OI. Remember, the O and the I added together must be negative 4x. So I need two terms that I'm going to multiply together and get negative 21, which means that one is positive and one is negative. But when I add those, I'll get this coefficient of negative 4. And so the answer to that is, well, let you think about that for a second. So pause it and think about what two numbers would multiply to be negative 21, but add to be negative 4. Okay, the answer is, it has to be negative 7 and positive 3. So if I, just to check to see whether I'm right, if I did FOIL these two binomials, x times x would give me x squared. The outer x times positive 3 would be 3x. The inner, or the I part, would be negative 7 times x would be negative 7x. And the last, sorry about that. And the last would be negative 7 times 3 is negative 21. And then again, that result for the O and the I combined to be negative 4x. So this indeed is the same as that. Okay, who cares? Well, the reason that it's important is because now once I have unfoiled or factored the trinomial, original trinomial, into two binomials, now this is a product where a times b equals 0. A is x minus 7, and b is x plus 3. And so from the zero product property we've been talking about, x must be 7 or negative 3. So give your attention over here, look at this one, and see what two binomials could you unfoil this to make. In other words, what did the two binomials look like? If you FOIL them together, you would get this answer. So we're going to factor this trinomial into two binomials. And your attention should be here first, and then there second. And then finally, how do you get that O in the I? All right, pause that a minute. Give it a shot. All right, the answers are that to get x squared, it had to be the first terms are x and x. Secondarily, to get negative 96 as the last term, two things that multiply to be negative 96. Well, one has to be negative, one has to be positive. Which one would be the bigger, negative or the positive? Well, for the O and the I together to be negative 4x, the negative one has to be 4 larger than, its absolute value has to be 4 larger than the positive one. So you were looking for two numbers that are 4 apart that multiply to be 96, and that would be negative 12 and positive 8. Because negative 12 times 8 is 96, and my check is, if I do the outside and the inside for FOILing, I would get 8x and negative 12x, which would add to be the O and the I of negative 4x. Once I have this, now it wasn't a product before, now it is. X minus 12 times x plus 8 equals 0, so x minus 12 equals 0, which means that x is 12, or x plus 8 equals 0, which means x equals negative 8. So those are my two answers. Okay, I want you to factor these. Now again, these are actually only binomials, so you're just going to factor one term out to get your product, and then use the zero product property to solve. See if you can do both of these. Okay, so I've done the top one. The common factor is that goes into both x and 6x is certainly, x squared and 6x is x, goes into both of these. So I factored that x out. And so I undistributed the x, and this would have looked like x plus 6 before it would have distributed in. And so now a times b equals 0, x equals 0, or x plus 6 equals 0. And that gives me my two answers of 0 and negative 6. The second one, 6x squared minus 12x, not only do they have x in common, but they also have a 6 in common. So I factored out a common factor of 6x. So it became 6x, and then the distributed property to get x, 6x squared minus 12x, is 6x times x. This gives you that. 6x times negative 2 will give you that. Now we have a product 6x times x minus 2, so we can use zero product property. So either 6x equals 0 or x minus 2 equals 0, which means that x equals, if I divide by 6, 0, or if I add 2, 2. All right, so you're going to try this one. All right. Change this trinomial into unfoiling to two binomials that would have foiled together to give you this. Give that a shot and come back when you think you have an answer. Two answers, right? Two answers. Okay, so the two binomials have to start with x and x in order to multiply to be x squared for the first terms. And then I look at the last term of 10. And my question to myself is, what multiplies to be 10, but adds to be 7? And the reason I choose 7 is because that's what the coefficient of the O and the I is. And obviously that's 5 and 2. So that means that the two constant terms in the binomials are positive 5 and positive 2. Now that actually isn't the answers, that ends up being the opposite of the answers. Because if x plus 5 times x plus 2 equals 0, and x plus 5 equals 0, which would make negative 5 the answer for x, or x plus 2 equals 0, which would make x equals negative 2. When we say the answer, right, if you took either one of these and plugged it back into the original equation, you would get 0. All right, we're going to practice this. Namaste. Thank you very much.